Okay, let's cover 740-741 Lesson 5, Managing and Maintaining our DHCP. So understand that your objective in this may include, it's not limited to, configuring a lease period, backing up and restoring DHCP database, configuring high availability using DHCP Failover, DHCP name protection, and troubleshooting. So let's cover a couple key terms. There's only a few key terms in this lesson. DHCP Failover replicates lease information between two DHCP servers. DHCP Failover was introduced in Windows Server 2012. DHCP name protection. To prevent non-Microsoft systems from overwriting systems that use static addresses, Windows Server 2012 introduced DHCP name protection to prevent these conflicts. Split scopes. Split scopes use two DHCP servers to assign IP addresses. 80% of the available addresses are assigned on the primary server, whereas 20% of the available addresses are assigned to a secondary. If a situation occurs where the primary server is down, the secondary server can assign IP addresses long enough for you to fix or replace the primary server. In configuring scope properties, we can access the Properties tab for our scope, and within there we can see and adjust the starting IP address, ending IP address, the lease duration time, as well as accessing the DNS tab is where we do our name protection, as well as the advanced tabs. As we previously mentioned, the DHCP name protection is there to prevent non-Microsoft systems from overwriting systems that use static IP addresses. To enable this, you would right-click either IPv4 or IPv6, choose the properties, and then select DNS tab in those properties. And it's as simple as click in the name protection section and then check to enable name protection. In maintaining our DHCP database, it's critical to know how to perform a manual backup and restore the database in the event of a disaster. It can be beneficial to separate the backup path from the default DHCP database location. In other words, don't put your backup in the same room where the fire occurs. If a disk were to fail that contained both the DHCP database and the backup database, then the design of the DHCP resiliency was not properly planned for. Understand that the database automatically backs up synchronously every 60 minutes by default. You can change that interval by going into regedit and modifying the following registry reg dword. If you'd like to do a manual backup, simply open up DHCP Manager, right-click the DHCP server, and choose Backup. You'll browse for folder, you'll navigate to and select the desired destination path, and click OK. With most everything we do, the goal is to maintain availability. So DHCP is no different. DHCP is an essential service that allows most clients and some servers to communicate on the network. As clients are turned on, or when a client renews a lease, the DHCP server must be available to assign or renew the lease. Therefore, you need to take steps to ensure DHCP services are always available. To do this, we can use split scopes, server clusters, DHCP failover, or standby servers. A split scope, as we previously discussed, uses two DHCP servers to assign IP addresses. 80%, it's also called an 80-20. 80% of the available addresses are assigned on the primary, and 20% are the remaining 20% are assigned to the secondary. If the primary server goes down, the secondary server can assign IP addresses until you resolve or fix or replace the failing server. A server cluster, as we saw in previous exercises, uses a failover cluster to host a DHCP server. DHCP Failover replicates lease information between two DHCP servers. DHCP Failover was introduced in Windows Server 2012, or the use of a standby server, utilizing a hot standby DHCP server with identical scopes and options as the production. Be sure that if you restore a database server from a DHCP database server from backup, you need to make sure that the DHCP clients do not receive IP addresses that are currently in use on the network. This can be accomplished by opening the properties of an IPv4 node, clicking the Advanced tab, and then setting the conflict detection value to 2. So split scopes, we've covered this twice now. It's also known as an 80-20 configuration. We'll be doing this in the lab if you've not already done the lab. Failover, DHCP Failover. So with DHCP Failover, you can create a failover relationship between two DHCP servers. Failover supports two modes: load sharing, where both servers simultaneously supply IP configuration to clients, and by default the load is distributed evenly 50-50, or 50% and 50%. You can adjust the ratio if you prefer one server to another. Load sharing is the default mode. You can also define it as hot standby, whereas one server is the primary server that actively assigns IP configurations for the subnet or the scope, and the other is a secondary server that assumes the role if the primary becomes unavailable. This is best suited for situations where you're going to configure a disaster recovery site that's in a different location. So DHCP is one of those services that nobody even thinks about until it doesn't work. Users will turn their computers on in the morning or reboot, reset, whatever it might be. They simply assume that they're going to be connected to the network and subsequently to the internet. It just happens. However, what happens when they are unable to do so? We examine the computer and it's been set with a 169.254 IP address, an APIPA. What are the two most common scenarios in which an APIPA will be assigned? One, the first thing you need to check, is the computer connected to your network? Is there a faulty cable? Is there a faulty switch? Is there a break somewhere? Is there a reason why that device cannot communicate with the network and subsequently the DHCP server? The other scenario might be on the DHCP server. It could be a DHCP relay agent that is misconfigured or changed or been removed. It could be the DHCP server itself if all the leases have been consumed. If all the IPs have been handed out and a new client attempts to connect, it's going to turn around and give itself an APIPA because it will not have been assigned an IP address. All the different ways to do troubleshooting for DHCP. So in this lesson, a fairly brief lesson, we talked about database maintenance. We talked about DHCP name protection, how critical it is to know how to perform a manual backup and restoration of a database in the event of a disaster, the fact that you never want to store your backup in the same location or disk as the actual operational DHCP database. The fact that DHCP is an essential service that allows most of your clients and some servers sometimes to communicate on the network. As clients are turned on or when a client renews a lease, the DHCP server must be available to assign or renew the lease. Thus, you need to take steps to ensure that your DHCP services are always available. This is one of the pillars of cybersecurity as well, availability. To make it highly available, you can use split scopes, server clusters, DHCP failover, and standby server. And understand that when a DHCP enabled client cannot obtain an IP address, it will automatically configure itself with an APIPA 169.254 address. Thank you very much for going through lesson 5.